Hi, this is John Henderson, and I'm taking the Statistics 1 course on Coursera. This is just a quick video tutorial on getting your data into R. I did make a tutorial in the forums with a bunch of pictures to try to help you do the same thing, but from the comments I can tell that it's still causing some of you some grief, so I thought that a video would hope to ease the pain, and I just hope that many of you stay around if we can get you past some of the first difficult steps with R, which I admit are difficult. So here we go. So the first biggest thing I've seen come up is where the data is actually stored. So if you look on the left, there's an R Resources tab. If I click that, this is where Professor Conway is keeping the lab data. So in the lab videos where he's teaching you R, you are going to see two files. The left column, lab 1, 2, and 3. Those end in .r, and they're actually R script files that contain the code that he's using in the videos. So if you download those, you can open them in something like R Studio. If you just Google that, you'll find it. It's a program where you can open up R script files and run code very easily. In the right column, we have the actual data. So that's what you download if you wanted to read in his data. I'm going to use the quiz data instead. So completely separate from the lab data are the quiz data files. So to do that, you need to click on assignments on the left and then actually attempt to take the quiz. And buried, kind of hidden here in the introductory paragraph to quiz 2 in this example, is a link for the data. So if I left click that, which is a common reaction when you see a link, it opens up the file here. It can be a bit confusing because it looks like the SR column is blank. Not to mention, how do I get this text into my session of R somehow? So I would just recommend not left clicking, or if you do and you see a file like this, just go back, and the best thing to do is to right click and choose based on your operating system and browser whatever is closest to save as. So save link as, save target as, save file as. So I'm just going to click that. Most computers will default to the downloads folder. You can feel free to choose another location and save the file. Now if we go into R, another thing that I think will help, or I hope will help, is there's a big disconnect between this get working directory command. What does that mean? And that's not how I use my computer. I don't understand why the working directory is so important. So if we open up a file explorer, these two are literally synonymous. So if I'm looking at, if R says, hey, I'm looking at your documents folder, and I'm using File Explorer in my Documents folder, that means that they can see the exact same thing. So this means that whatever I see in this folder is the same exact directories and files that R is looking at, I guess in quotes there, figuratively, in the R session. So if you remembered verbatim the name of the quiz data file that I just saved and you told R to read it in, it would be exactly the same as me opening up this window that you see here before you, turning my computer to face you and saying, hey, can you open up that Stats 1 Homework 2 text file? And you would look at this folder and you'd have no idea what I'm talking about. So we know, however, that the file is in our Downloads folder. So that's where we need to point R so that it actually knows about the file. So on Windows, one handy trick is if you click up here in this bar, it will turn that graphical representation into the text path. And so that's the magic that we need to make R work. With the exception that Windows uses these backslash characters and R uses or prefers / characters. It might even give an error if you use backslashes, so we won't do that. But let's say you save this file in a much more complicated location. You have a folder dedicated to Coursera. You can just click up here, which I will do, select all of that text, and I'm pressing Control-C to copy the text. And now we can set our working directory with set WD and use quotations, paste in the path, close the quotations and the parentheses, and now just arrow back and change all of the slashes to the other kind of slash. So backslashes to /slashes. We'll try get working directory again. And now we're looking at the downloads folder. We can confirm that by using the dir command, or dir, which will list all of the files in that folder. And we see we have the file that we want to read in. And now it's as easy as read table. And if I type the first few letters and then press tab, R will complete it. So that's a nice handy trick. Can save you some spelling errors or just copying errors when you're typing. And there we go. So there's the data. However, so this is the default action, is just to, so read table means, hey, look in that file, read out the data, and print it to the screen. But we want to store it because we're going to want to do different computations on the data. So we'll store it as something called data. So this means take the thing on the left, and this arrow means take whatever I type on the right and store it in something called whatever's on the left. So we're creating something called data, and we'll just type the same command again using tab to complete, and header equals true, and we see nothing. So this can be a little bit confusing sometimes. R doesn't say, hooray, successful. It just doesn't tell you that there was a problem, which honestly is a good thing. If you're not seeing any errors, it means you're probably doing the right thing. If we type head data, that shows us the first lines of whatever is in the thing called data, and we know that we stored the file in data, so it should show us the first lines of our data, and it does. So when I first typed that command up above, I intentionally left off that header equals true argument just to show you what happens. So if you leave that off, R will assume that every line in your data file is part of the actual data. So here our column names are actually V1 through V4, these sort of generic column names, just variable 1, variable 2. And you can see that the column names that we know should be the column names are actually assigned as a row 1 in the data. So that's just something to be aware of. That has negative implications because in this fourth column we should have a bunch of numbers, but since we stored this SR character string in that column, R has now converted this whole column into the text equivalence of its number counterpart. So that 11, even though it looks like 11, is really 11 with quotations around it. So if you tried to calculate the mean of the fourth column of this data set, you would just get a 0, or you might even get an error. I don't remember what R's typical response is, but it won't be the mean of these numbers. It'll be something nonsensical because R can't take the mean of letters. With the header equals true argument, we get the proper result. So we can see that there's no row number next to this row here in the data. It's just blank. That means that those are the column names, and then row 1 starts with the real data. So all is good. So that's the first way. Save the file to your computer, read it in. I'm going to go back to the quiz data, and this time when I right-click the link, I'm going to choose Copy Link Address. Again, whatever seems most similar to that based on your browser or operating system. And now I'll call it quiz this time just to show you that it works, and say read table again, quotation mark, and paste, and again header equals true, and I will end my parentheses, and then this time before I hit enter, just go back to the beginning of the address and delete the S. So that stands for secure HTTP. R can only work with standard HTTP protocol. So if you delete the S and hit enter, and now I use head quiz, it worked. So R just went out to the internet, grabbed that file, and then read it in and stored it as something called quiz. So those very quickly are the two ways to get your data into R, either from a file or directly from the web address. Again, remember that it is going to be called whatever you typed on the left, and you can quickly find out what variables R knows about with the ls command, and you can see that in our session here we've defined 2, and that should hopefully erase some confusion there. For example, if you see Professor Conway type dim impact in a lab video and you go to follow along and you don't see an impact object, it's probably because he used impact when he read his data in, and you used either quiz or data. So just adjust your commands appropriately. So hopefully that helped, and I will see you around the course.